Hi guys, this is Tempest, and these are two of my machines. This is the SR6 and this is the OSR2. These are both flashlight wielding robots. Flashlight. Like so. Now these machines are both based on hobby servos. Like this. This is a 20 kilogram centimeter servo and driven from a microcontroller like this one. It's an ESP32. Now it's not the easiest thing to connect up a servo to a microcontroller, and yet when you can do it, you can do all sorts of really interesting things. So this video is a video I recorded about 3 years ago for my patrons, which shows how to make something I call a power bus, which is a way of connecting these servos up to a 6-volt power supply and controlling them from the microcontroller, when of course there's no obvious way to just plug the servos in. So I hope you enjoy. I hope it's useful. It's useful for projects that aren't adult toys. And if you are interested in building one of these devices or one of my newer devices that uses brushless motors, then check out my page on Patreon or Subscribestar, and you'll find a lot more content like this. I've got about 80 hours worth of live stream content from which this was made. I also do step-by-step build instructions for both of these devices, complete with parts lists and all of the 3D print files you need to make the parts. So do check that out. But in the meantime, enjoy the video. Hi guys, Tempest here, and in this video I'm going to show you how to make this, which is a power bus for an SR6. Now we need a power bus because the ESP32 that controls the servos in an SR6 doesn't have any other way of connecting up the power to the servos. So we'll do that using this. So it has two rows of pins that we use to power the servos, a power socket that your power supply connects into, and a switch that you can use to turn the power to the servos on and off, which is very useful. So in this video I'm going to go through how to make this. It's a very good project as well, I think, if you've never done soldering before, because it needs a little bit of soldering, but it's a very gentle way to get into it, and you don't need a huge number of tools or specialist skills really to work on it. I'm going to take you through it step by step. It's worth also adding that this can also be used in an OSR2, although with slightly different wire lengths, so consider this as a guide for both. So these are the materials you're going to need to build the power bus. What you'll need is some copper strip board. So these are 0.1 inch pitch holes with copper strips running lengthways. You will need a power jack connector. It needs to be compatible with your power supply. I've gone with this one because it's got screws, screw connections, which are going to make things a little bit easier, especially if you want to chop and change things later. It also helps because it has a plus and a minus on it, which means it's if you're soldering it yourself, you'll be a little bit less confident you were getting the positive and negative terminals right. A fairly chunky switch that will fit into the lid on your OSR2 or SR6. These, which are a set of pins, header pins, and they're 0.1 inch header pins. They will slot into this. And wire. This is a point I want to hammer home in this tutorial, which is that the wire that you use for your power bus has to be very good chunky wire. You can't go for thin wires. If you look at the kind of wire that you get on a servo connection, these wires are probably enough for an individual servo, but the problem is that with the SR6 we could be dealing with quite significant currents. And even an OSR2, if you're using servos, big servos at a high enough level, and if you have a wire that's too thin, it's going to start generating a lot of heat and potentially start a fire if you're not careful. So the guide that I would recommend when you choose wire for your power bus is look at what the maximum current rating of your power supply is. So for example, I'm using a 10 amp bench power supply, and then when you choose your power bus wire, choose a wire that is rated to a higher current than your power supply. So this wire here is quite thick and it's rated to 16 amps. So this should be absolutely fine. It's not going to get hot. But I can't emphasize that enough, guys. Nice chunky wires for your power bus, especially now we're dealing with 6 meaty servos. The last thing you'll need is one of these, which is a servo extension cable, and I'll explain what this is for later. So the tools we're going to be using, we've got a file here, I'll explain what that's for, a pair of pliers, a Stanley knife, a good strong knife there, a small craft knife is useful for more delicate stuff. I've got a screwdriver here because there are screws on the connector here, and electrical tape. You can use heat shrinks if you've got the kit to do that, but I'm going to show you how to do this with electrical tape because buying a roll of this is much easier than going in and getting heat shrink stuff. So let's get started. So the first thing we need to do is we need to cut out a piece of this strip board that will form our power bus. So I'm going to show you the best way I think of doing that. What we want is a strip with 2 of these tracks running 10 pins and then another extra couple to solder the on-off wires onto it. So what we're going to do is we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, and then from here, and if I mark that off so I can find that, what we can now do is we can, so we're going from hole to hole across here. Like so. So I'm literally wanting to score across there like that, and then I can do it on the other side as well. So we're wanting to link all of the holes with a scoring like that. And then what we can do is, because the holes are a weak point and we've made them even weaker, and I practice this off camera, is we can literally break that off like that. So you can get rid of this. So next what we need to do is we need to do this again lengthways. So on this one you need to be a little bit deeper with the cut. But the good news is if you get it wrong, you can do a lot of tries to get it right. Okay, this is what the pliers are for. So you're not looking to do it all in one go. Do a little wiggle, and that comes off like that. Now here's the test. Can I do it again? You need to get it right twice in a row. Okay. So yeah, you do it on both sides, and then I'll show you again. Nice good grip with your pliers, and imagine, doesn't need any force really, you just a little wiggle back and forth and off it comes. So next what we want to do is we want to make it so that it will fit this. So this is a little doohickey that I'll be including with the SR6 release and probably OSR2 releases in future. And this is a thing that we can use to mount our finished power bus to the ESP32 in a convenient place. So what we want, you see we've got an end here that we want this to fit into there, and at the moment it doesn't quite fit. So we use a file to make it fit. So literally take some off both sides, a bit tight, so you want a nice even on both sides, but a nice tight fit like that. So yeah, that should just slide in like that. So that's just right for what we are doing. So let's move on to the intimidating bit, which is the first bit of soldering. Okay, so for the soldering, obviously you'll need a soldering iron that's hot. You'll want your sponge here that's wetted with water, and you'll want a nice clean tip, and get it nice and warm, a soldering iron. Now we need our pins. So these are our pins, and what we want with this power bus, we've got 12 holes here. We want 2 rows of 10 pins. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Break it off there. And to break them off, you literally just bend gently, and they're broken off. So is that 10? Yes, that looks like 10. We get a second one the same length. So I stick my thumbnail in there and then just snap. So we have 2 sets of pins here, and literally what we want to do is we want to insert these like so, and we want to solder those in place, so we've got 2 rails, if you like. So a useful trick is to use the strip board as a sort of jig for the soldering. So if I place the bus in there like that, and now soldering iron and solder, and literally all you want to do is you want to place the soldering iron so it's heating up the pin and the rail, and then touch the solder in like so. Now I've only soldered at one location, and this is very useful because if you look at the pins end on, you can see whether or not they're straight, and if they aren't straight, I only need to melt the solder at one place in order to give these pins a bit of a push and get them lined up. But I'm happy with them, so I'm going to do the same thing with the other row of pins. Okay, so that's both rows of pins held in position. If we look at them end on, you can see that they're all straight, they're all right down at the bottom there. So that's absolutely fine. So now all we need to do is solder the rest of the pins. But I do recommend doing just the two first, because if I had to adjust these, get the angle changed, there's no way I could do it if I'd soldered all of them. But with this I just need to unsolder one pin and I can wiggle it around. So let's solder the rest. And once you've got it, you can get into a bit of a rhythm. So guys, it doesn't need to be neat, but what matters is that you've got good solder connections between all of the pins and the tracks. And also that if you look in there, the solder, the metal doesn't actually bridge the two rails. If you've got a multimeter that can check the resistance between the two, that's a good way of checking. Maybe if you've got a battery and an LED or a light hanging around, that might be a good way to double check it. Either way, be very, very careful when you plug this into your power supply for the first time that you haven't got a short. So if you turn it on and nothing comes on, turn the power off immediately. Be very careful, but as I say, what we care about here is that we don't have metal bridging the two tracks. And then you want to check that with this extra metal work on there, that it still fits snugly into the holder. So great, let's move on. So now we've got this soldered up, let's move on to the wires. So I'm going to do the ground first. And for the ground we need two components. What we need is we need to link the power supply connection to one of the rails on the bus here. And what we also need to be able to do is we need to be able to link the ground on the bus to the ground on the ESP32. And one way that you could do that is get a bit of black jumper wire and a crimper and crimper connection onto the end of it. But of course, just for this one connection, there's no point in you buying a crimping tool, so I've got an alternative for you. This is a wire extension, a servo wire extension. I recommend getting hold of a bunch of these because they're really useful if you need to do any of this sort of work with wiring. And the wires in the end of these have already been crimped for you. There's a metal connector on here. If I insert a craft knife into this little plastic lever here and push it up, I can actually pull out this wire. And you can see that this wire has already got a crimp connector on the end of it, so you don't need to actually bother crimping anything. You can get one of your single covers put that over it, and you've got a wire. So you just pull this off, and there you are. You've got a ground wire to go onto your ESP32. And I think that's a very neat solution for what we're doing here. So we don't need a lot of wire for the ground, so about 10 centimeters should be enough. So take your knife, and we're looking to just cut of course the lengths I'm using here for an SR6, but if you're fitting this to any other machine like an OSR2, I would recommend double measuring the distances you need first. So got a length of wire here, and we can roll it with a bit of gentle pressure under a craft knife. Of course, the insulation's quite thick, but there we go. There's the wire. So roll again. And roll again. So expose the ends here. This end is going to be quite easy. It will just go straight in. It'll go into the negative side on there. The other end we will have to solder. So let's get on with that. Okay, so obviously this cable's too thick to go through one of the holes on this strip. So what we're going to be doing is soldering it down like this. Now there's a trick to soldering two components together, especially something fiddly, and that's to get solder onto both halves of the joint before you introduce them to each other. So let's do that. Let's put some solder down here first, and it doesn't matter which row you're using as long as you get it right when you plug the servos in. So we'll just put some solder on there. I'll do the other side whilst we're at it. And what you'll find is as you heat the rail up, the solder will stick to it. Now with the wire, let's position that so you can see it. We just want a bit of solder on the wire itself. Like so. Now what we should be able to do is, if I press these two together and melt the solder, it should just merge the two into one joint. Fingers crossed, everybody. Now the ESP grounding wire. For this we need a little bit shorter. Don't cut it too short, but I don't know, about 7 or 8 centimeters. So about there should be more than enough for what we're doing. So get rid of that, and then much gentler this time, remove the insulation. So the same procedure again. I want a tiny bit of solder on this bit of wire, and we'll just merge it into this part here. So So now we just merge this wire in like so. Okay, so now the power. So the power has to do the same thing. It has to go from the power supply to one of the rails. But it also has to go via this switch, and in the SR6 that's from the bottom of the machine enclosure to the top. So what we actually need is about 30 centimeters each way. So that is about that. So we'll cut it off there. Okay, so we have two lengths of power cable. Let's solder one of these to the power bus. So there we are with both wires on there, and what we care about is that there's no metal to metal contact between the two rails. And now we're done, of course, the other thing we can do is scrape between with a knife just to make sure there's no metal in between, and make sure you blow out any dust, any of the dust left by the flux residue. So now we're going to seal it up. So what I recommend for sealing this, I'm going to be using a heat shrink, but the easiest thing that you can use is some electrical tape. So you pull a length of it out, and then you can just wrap it around this. So there we are, that's sealed it off. And there is your power bus. Okay, so next we need to install the switch on the end of these wires. So the way you need to wire the switch is the middle has to connect to one of the outside ones, depending on which way the switch is. What I tend to do is I tend to wire up the power in, which will come from this one, to the middle, and then choose one of the outsides as the one that connects to the power bus. But that's the crucial thing to use, to connect from the middle to one of the outside ones. If you connect from outside to outside, then you won't get a connection when the switch is flipped. So middle to outside. Okay, so that's soldered one wire. So again, what we want is a piece of electrical tape, a short piece of electrical tape, and you can wrap it around. An uneven fold is best, because with an uneven fold what you can do is then wrap it around the cable like so. So that's that soldered in there as well. So that's off and that's on. So let's get some more tape and cover that up. There we go. So that's that finished. Okay, so that's the switch done on the end of here. We've got our power bus down here. So the last piece is to install the power socket. So this one isn't too complicated, it's just a screw connector, so let's do that. Right. So literally just insert and screw with this one. Yeah, there we go. So there we have it. This is the finished power bus. So we have our rack of connectors down here. We've got our ground lead for the ESP32 that comes off the ground connector. Ground connector goes to the socket over here, and of course we've got these two leads that go to the switch, and they're long leads on the SR6. If you're doing this for an OSR2, then you probably want slightly different wire lengths, so check those before you build it. But there we go, that is our finished power bus. And that's it for this tutorial, guys. I hope this has been useful. Do leave me a comment if you have any thoughts on what I should be doing next, anything you'd like me to elaborate on or give you more information on. As always, a big thank you to all of you for supporting my work. And if you're not yet on the Discord server, be sure to join us there, and hopefully I'll see you on the next live stream. Take care.